Good morning, everyone. This is Jim Chastain with EasyPower. Welcome to our Thursday webinar series. Today the topic is the top 5 reasons you should request a data file after an ARC Flash study. I actually want to rename this the top 5 reasons I, as a consultant, should share the digital file after an ARC Flash study with my client. And as I get into this, hopefully you'll understand my thought process. Again, appreciate everyone joining us today, and let's jump into the topic. I really have 2 agendas, and based upon your perspective, it may even depend on how you appreciate or how you take the discussion. From a client's point of view, if you consider the cost of the ARC Flash study as an investment, you should expect at some point in time to recognize a return on that investment. And what I'm about to show is how that return is manifested and how over time that actual return can grow. And specifically, part of that value is in a higher ability to communicate and to utilize engineering resources. And the primary focus for that will be, I maintain, the person that helped me develop the data file itself. Now, from a consulting firm point of view, I want you to consider the study as a first step in a continued support and maintenance scheme, a path that's longer than just a one-time event, because as you do the ARC Flash study, you will develop system knowledge that's extremely valuable to the client and is not necessarily conveyed or not completely conveyed in terms of the reports that are normally provided. I maintain, and what I plan to show, is that the database itself is the conduit to a better communications link with that client or with a series of clients, if you could follow this methodology, because you're expanding, you have the ability to expand your value proposition to even an existing base of our customers. From my point of view, there are some basic facts I think to take into account. First of all, plants and factories, according to trends, are continuing to and more expected to outsource facility engineering functions. And since there's not a change as far as the graduation rate in power systems engineering jobs or degrees, these jobs then will be picked up by consulting firms as the jobs themselves migrate away from in-house engineering functions. Now, how that connection will be sustained, how plants who need engineering functions utilize the engineering firms, is a little bit up in the air right now. There are some facility maintenance companies that are offering a cafeteria plan, if you will. And the point being is that there's a checklist, and if I need a service that's on a checklist, we put it on the schedule. Where I would suggest that there's some failing in that or some shortcoming in that is with increased communications, there are actually some services that I as a client may not recognize I need, and not necessarily on a routine basis, but that would be uncovered if I have a better ability to communicate via a link like this database. So I think the customers that are inclined to gravitate towards this way of thinking will have the attitude that don't try to sell me more than I need, but stay ahead of the list of the things that I do need. And I, as a consulting firm, an engineering resource potentially for that company, if I have a way to increase that communications link and a way to be proactive that I can demonstrate instead of just a reactive footing, I think the customer will recognize that as a value added for his organization. Now, where I'm really going with this line of thinking falls more into the line of strategic marketing or solution sales. In essence, it's a comparison between a transaction sale and a solution sale, where the fact that a particular client or a customer required or had the need for an ARC study, and we were able to win that transaction, is not really where we should think in terms of the relationship ending. I think the fact that he had a need could be an indicator of more activity, more needs behind the scene, more solutions that may be of benefit to the client, but he may not even realize that that a solution is needed or that a solution is available. Nevertheless, the fact that we have this initial engagement with him is an opportunity for more conversations down the road. And I think part of the reason for him reaching out for this assistance potentially points to an underlying bandwidth constraint, where even if he has the skills in-house, there may be time constraints or some other level of interference that he may not be able to attend something as dire as NFPA 70E compliance. And if he can understand how a better communication link with me as his engineering resource would allow him to stay ahead of his preventive maintenance, I think he is inclined to listen to that type of a discussion. Now, I understand people thinking that if they have the data file and the customer needs to renew his study, then obviously I have an advantage because I have the data file and nobody else does. I think that's a short-sighted approach, and frankly it's one held by a lot of consulting firms, and I think what I'm about to describe is an opportunity to stand apart from the crowd and not only offer the data file as an element of value, but by explaining or educating to the client what additional information can be extracted from it, how he can participate in that procedure and improve the ongoing communications, I think will develop trust and build confidence in what's being delivered. And in many cases, it'll be more than just what's being initially asked for, as the customer starts to recognize this increased benefit of the system knowledge. So what I maintain is that this is a way to develop real-time value, not just something that you touch the customer once every 5 years because that's what government regulations require. So that brings me to reason number 5. One of the reasons that I would want the file as a client, and that I think a consulting firm should share the file, is that primarily, or first and foremost, in both OSHA requirements and NFPA requirements is the need to maintain a current one-line diagram. And whether changes are big or small, having some ability to upgrade that data file benefits the customer in the long run. Some of these may be reflected in panel load changes. Because our study may not have included any panel loads, he may want to go down that path to increase the validity of the data file and utilize it more in his maintenance schedules and in training. But the point is, if he doesn't have that file to start with, it's going to be difficult for him to participate whether or not he thinks he needs that initially. Now, the point I want to make here is that extra, that data entry point from an EasyPower point of view can be done with several EasyPower modules, and in some cases they're actually low risk if I consider a point of conflict in terms of the customer doing something with the file. These modules include One-Line Designer, which just allows me to make changes to the system, and if any analysis needs to be done, the file still needs to be sent back to the originating consultant. Or another file, another module that can be used for this is the Power Flow module, which allows me to do changes to the one-line diagram because the database editor is built into the standalone module. But and still I can do, as a user, I really can't do any additional analysis in terms of short circuit or arc flash, but the ability to look at power flow opens up a whole new realm of discussion that is not covered in the short circuit arc flash environment. So to springboard off of that, I want to make a very strong case for the fact that there's more value in the data file in this particular way of looking at it. The arc flash model is actually an ideal system model because it's based on nameplate information. Most loads, as we set up motors or panels, are set for 100% run load in the power flow tab, and as such, that does not necessarily reflect the real system. So converting the data file that's utilized for arc flash analysis into one that can be utilized for power flow really falls into the realm of tuning the model to reflect actual loads. There's and then the process of extracting data or understanding more my load flow results is a matter of resolving the delta between measured parameters and predicted parameters going forward. Well, the real parameter data sources, again, have to come from my actual system, and they can be collected in a number of ways. First of all, there can be panel meters that could be on the different parts of the system, and we can collect that information manually. In fact, if you have attended any of the tutorials on labels, you'll see that the EasyPower tools can actually generate labels with a QR code on them, and you can utilize, the customer can utilize that QR link to be able to allow his electricians to enter panel meter variables, for instance current and voltage, on a spreadsheet that they would data log that entry and allow him to use those variables to update his power flow readings, power flow model. You can also utilize temporary data loggers. Of course, these need to be manually set up and moved around, and you need to take some time to coordinate the time, plant operations, and seasonal variation to get the true value from those readings, and part of that would have bearing on what you're trying to do with the power flow model. Another relatively common system feature is the Stata system that many factories have installed for supervisory control and data collection, and it's EasyPower's ability to import SCADA data that makes this whole process of tuning from an ideal system to a more practical, realistic system relatively easy and simple. So what I'm going to do next is march through a process that can be done either by the consulting firm or taught to a facility manager or a maintenance team to take the SCADA measured data, import it into EasyPower data file, and again, garner the benefits of doing a data flow analysis with real data. So what I'm going to do is import the data, resolve the power flow, establish the system to track trends on the key parameters. Steps that I'm going to take to do that: first, we're going to run the power flow just to show what the results or the reports that can be generated, and pick out some typical parameters that we may want to trend or track the trends. Then we're going to export the SCADA file as a format from EasyPower, and then manipulate that so it can align with the formatting of the SCADA information we're going to receive from our SCADA system. We're going to copy and paste the real data back into the EasyPower CSV file, import that back into EasyPower, and then run the power flow. So let's jump into that and see how it all works. So the example I'm going to use is actually one that's in the sample file. It's DS example 2, and if you have the EasyPower tools installed, this will be in the sample folder. Now, just to show, for instance, what I'm talking about, as we open up, we're in the database editor. We've entered all of our specifications for the motor size, the power factor, and the efficiency from the manufacturer's datasheet or the nameplate. Normally, then we've calculated a short circuit current, and we've decided to plot or not plot the thermal limit curve on the TCCs. Normally, we don't mess with the power flow, so we usually leave it at its default 100% rating, but we're showing here that the load model is utilizing the motor specifications. So what we want to do is import the SCADA data, and from the imported information, run the model there. And you'll notice in either case, the motor specifications or the SCADA parameters, there are 4 different models used to describe the motor operation and the model. And if we go to the help file that's built into EasyPower, the context help, and the power flow tab, you'll see a description of what each of these models represent and what it means as far as utilizing the data from a SCADA download. So while I'm here, I'm going to go ahead and run a power flow model using the motor specifications. And as we solve the equations, look at the text reports that are available. So you can see we can have a detailed report or specific summaries, and after 1 or 2 runs of the power flow, there may be certain elements that we want to track. Let's go ahead and do the IEEE report first and look at what it shows us. So this shows us all the energy flow in and out of a bus, and the point being is that the net supply equals the total demand, and thereby giving us an idea of where the losses will exist. And so I'm going to go ahead and generate another loss report. Let's look at loss summary just for an example. And you'll notice the window reduces in size, and that's because it's trying to show me I have that report available down at the bottom of the screen. And so here's a summary of what the losses are at each of the buses. All right, so let's go ahead and save this in Word and assume that this is what we want to track over time, or we've made a decision to look at it later on after we get our real system up and running, our real database. Okay, I'm going to go back to the database editor. First thing I want to do is actually generate a SCADA export so I can see the format that EasyPower will accept data in. So to do that, I want to export a CSV file, and here I'm going to select the SCADA data file, and I'm going to put it into a folder that I will keep track of. So this case, we're going to call this SCADA All right, so we're going to save that here. Now we're going to go back and look at that particular file itself with Excel. So here's our SCADA DS example. So here's what EasyPower just downloaded. You'll see I have all my motors listed. We really have a few other elements in this system, but the SCADA accommodates generations, utilities, loads, motor control centers, and panels. And so we have a minimum amount of other items, so we're going to stick with motors for now. So first thing I see is that the model for the motor spec, manufacturer spec, and the SCADA is intertwined. So I'm going to do a custom sort to be able to separate those. And to do that, I'm going to sort first on the column B, which is the spec and SCADA notation, and then I'm going to sort back on the name. And so now, if my SCADA information can be arranged, and here we're talking real power, apparent power, and then the model type as we're going to utilize it. And I have that pulled from my SCADA data dump from my data collection system, and have formatted it or rearranged the columns so I can look at it in this manner. And I've designated a motor load type to reflect what EasyPower is expecting. So I'm going to copy and paste, copy this, and take it back into the data file that we got from EasyPower. Now, I'm going to reformat this back so that it's in the order that EasyPower will expect it. Let's do our custom sort. And let's take out this one area here. Okay, so now this file is ready to be back imported now. It's got this SCADA information in it. So I'm going to save this as a file I'm going to call altered SCADA data, and put it in the same location. All right, so I can get rid of this, get back into EasyPower. Now at this point, I'm in the database edit. I'm going to import SCADA data. I'm going to import this from I meant to say altered, but I got ALR. And again, this is the SCADA data format. Now there's options when I do this that I can either overwrite some or all of the different types of equipment in the system. You'll see we don't have any motor control centers indicated because my initial file didn't have any. And for now, I'm just going to overwrite anything that was there in terms of existing data and replace it with the SCADA information. So we're going to go ahead and open that up. It found some errors, and you'll notice in the help file as you do this that they are header, basically blank header files that won't necessarily be there if we're using the file that's been formatted by EasyPower. All right, now if I go back and look at one of these elements, one of the motors, nothing's changed on the specification, nothing's changed on the short circuit. But if I look at power flow, you see now we're indicating that it's a SCADA-based model. We have the data that we imported from the SCADA file and then the load type. The scaling factor will remain at 100% because this is the real data, and at the time we did the data dump, this was the extent of the motor consumption. There may be some point in time when we want to do a what if and see what happens if we scale these up or down, but we're not going to worry about that for now. We're just going to take the model as it stands with current SCADA information. I'm going to go to power flow, solve the equations. We generated the report that we were looking at, I think was losses. So the point being now we have, based upon the time that we took the readings on the SCADA system, we have these indicated losses for each of the branches. Now, because this was our first order approximation, our first step, they still aren't necessarily exactly our actual physical system. There still could be some errors, and we want to take steps to do a bus-by-bus comparison to make sure we're not missing anything. Although what we've done with this import is override the motor load parameters, we still may have errors on our data collection when we did the study in terms of what the cable impedance is, the cable length, the number of conductors, and a lot of the elements that won't necessarily show up on the SCADA file. But in terms of bus voltages, bus currents, load currents, utility, and panel loading, this will be immensely closer to being a physical system than we started with just the ARC Flash database. Okay, next step then would be to save the trend, or save the plots, save the data, and then over time plot the trends to see if any of these losses change. And therein lies the value. So let's kind of go back to my next reason. And what we're doing now is we're identifying the trends by doing this SCADA import, let's say once a month or once a week or whatever my time system allows, and then tracking the delta between what changes week to week or time frame in terms of system losses. We can then do an optimization of some of the other preventive maintenance procedures we may have in place. We may want to, if we notice losses that we can't justify or explain, we want to schedule those particular systems for thermal imaging to make the operation more productive and avoid missing trouble spots. If we're not running, if we have a scan scheduled and it's not at the current, at the maximum load current, that say switching system or that bus or that motor would have problems where we could identify the heat signature, then having a prediction from the trend lines will help us optimize and make sure we scan those particular elements at a specific time or specific load. Okay, so reason number 4, we can actually better utilize resources such as thermal imaging and get better results as part of that investment. Then we go to reason number 3, and that is, if I had as a client, if I had the database, I do make changes that do affect my ARC Flash calculations. Having the database allows me to make changes and then send that file back to my engineering resource for updating the analysis, and then in return I receive updated reports and labels, and I'm able to maintain NFPA compliance with just a modicum of effort, again because I have that database to reflect or communicate back and forth. Now if the client would like to extend his ability to modify the system, by all means he has the ability to expand his knowledge of EasyPower and attempt to do the analysis update. But if he's as wise as we hope for him to be, part of that cycle will be to send the file to my engineering resource and verify that errors are not being introduced because of the client's lack of knowledge of ARC Flash analysis. Again, the tools take it only so far, and that's why I want to be connected with an engineering resource to make sure that I don't run astray. All right, so then that brings us to step number 3, and it's an expansion on earlier the optimization of the model, and that is, once we have our data file refined to match our actual physical system, and we're using a load flow analysis on a periodic basis, this gives us more capability to optimize my system in terms of understanding what my load capacities are at any particular time, what our ability to expand or deal with increased demand. We have the ability to discuss with engineering resources what our options are in case we have power factor penalty issues. Again, this wouldn't necessarily come up. In fact, it doesn't come up at all in ArcFlash, but it's because of this dialogue on load flow and improving the model. And the more my consultant and I are able to communicate, the better we can respond to recommendations for cost savings. So again, the dialogue doesn't stop just because the client has more ability to do things with the database. In every sense, if I have taken care to educate him to the advantages of specifically load flow, there actually are reasons to believe that my extended communications with him will result in more potential engagement and more work rather than just doing a study every 5 years. And I got to believe that once a client understands the advantages he can achieve utilizing, or by better utilizing, the data file that he shares with me as his consultant, I believe we've reached this higher level of incorporating my resources, improving the communications link, and improving the trust factor, because now the client will better understand the value that I'm bringing to the discussion. So that brings me to the number one reason that the data file should be shared with clients. And from a client's perspective, hey, it's your data file. Why shouldn't you have a copy of it? And along with that, the better I understand the value of that data file, I can understand that this utilization will improve the two-way street rather than just always having a transactional basis with resources that I need to be able to trust. And then clearly there's an excellent what-if resource to be able to bounce ideas off of my engineering resource without having to make a big disclosure or study out of a new project, and migrate along the path of expanding my needs and being able to take my consultant better into my confidence in terms of knowledge of the plant. From a consultant point of view, I think it's misguided to think that I have any kind of control over the client if I'm withholding information that clearly is only relevant to his system. In fact, there's some potential downside to thinking that that I'm intentionally withholding something that would be useful to the client. Secondarily, I think if we look at the ArcFlash study or the ArcFlash engagement as an opportunity to help better educate the client, extend his ability to do his job more efficiently, and increase the communications link that he should value with his resources, I think is a very clear extension of the value proposition that I'm trying to establish with the client base. So the bottom line, EasyPower increases productivity on several different levels. The constant pressure to do more with less is going to affect large companies and small, and improved access to resources and communications is a vital part of that equation. So what I believe we represent is the ability to establish tighter coupling between a facility or facility maintenance organization and an engineering resource, and by utilizing that connection to expand client understanding of his system and his working knowledge will bring me in a better standing to be able to do more work with that client down the road. So just to kind of refresh, the top reasons, in my opinion, to share the ArcFlash data file between clients and consultants. Number 5 is to expand the one line beyond just the scope of the study, because there's panels and there's loads that may not have been detailed on the ArcFlash study just because they weren't required, but as a client, I'd like to have a better and more accurate list of schedules. The ability to convert that ARC Flash database into a more realistic database using SCADA data allows me to do load flow applications and expand on more knowledge of my actual system for both analysis and what-if discussions. Thirdly, it does allow the ability to update the study as needed and exchange files with my engineering resources either to complete the analysis or to check the analysis. In either case, it's considerable cost savings in terms of maintaining compliance and minimizing worker safety hazards and a better confidence that the employer will have with his workforce. Number two would be to help him optimize the system. Again, these can be recognized in terms of tracking trend data on the load flow study and consulting with him to interpret what the meanings of his system are and allow him to better utilize his resources. And then the number one reason is basically to increase the value and the utilization of the consultant. By having this link and being able to share the data allows me to, as a consultant, allows me to educate the customer, make him better understand the value that I bring to the equation, and at the same time, I think embolden his ability to do his job with a higher level of confidence that he has at his disposal more resources than the company provides him as a matter of staffing. Appreciate your time for today. Again, I encourage everyone to utilize the EasyPower.com website, both for the ARC Flash resources we have listed, but also we've just put up the regional training locations and schedules for next year, so by all means book early. Anyone with questions on this procedure as far as importing SCADA data, welcome to contact tech support at EasyPower.com or send me an email and we can help with any steps along the way, and encourage you to utilize the free demo versions of the tool on the website at any time. Thank you all for attending, and we'll talk to you in a future edition.